Welcome to NumPy Crash Course. We all know that Python has become one of the most popular programming languages in scientific computing, machine learning, and data science. NumPy is a cornerstone of the Python for data science and machine learning ecosystem. In this quick and short crash course, I'll help you to come up to speed with NumPy. So, let's start with the formal introduction of the NumPy. NumPy is a short form for numerical Python. It was initially written by Travis E. Oliphant in the year 2005-06. In fact, NumPy came out as a branch from a much bigger SciPy ecosystem. But what is SciPy? The SciPy ecosystem is a collection of open source software for scientific computing in Python. This is how it looks. Python is at the core of the ecosystem. You already know that Python is a general purpose, interpreted and dynamically typed programming language. NumPy is a package built on top of the Python language, and it was especially designed for high-speed numerical computations using array and matrices. At the core, NumPy provides two fundamental objects, n-dimensional array and universal function. We will learn about these as we progress with the course. But for now, let's look at the SciPy stack. The next layer of the SciPy stack consists of two more packages, Matplotlib and SciPy library. Matplotlib is a visualization and plotting package that provides high-quality 2D plots. It also comes with some 3D plotting capabilities, but those are just basic and not commonly used. The SciPy library offers a collection of numerical algorithms such as numerical integration, interpolation, optimization, linear algebra, and statistics. These two layers are the base of the SciPy ecosystem. On top of these, we have a bunch of specialized tools for data management and computation. Pandas and Scikitlearn are the two most popular packages from this ecosystem. Pandas offer you a data frame object for reading, writing, and processing in-memory data structures of different formats. Scikitlearn is an open source machine learning library that supports supervised and unsupervised learning. It also provides various tools for model fitting, data pre-processing, model selection, and many other things. The notion of SciPy stack was discontinued in 2017. This happened due to the advancement and disruption in the Python technology ecosystem. However, none of the packages were discontinued. They are still at the core of the data science and machine learning technologies. It is only the name SciPy stack which is not commonly used and popular these days. Great. So now you understand the origin of NumPy. But why do we need it? What is so special about the NumPy? Let's recall the concepts of matrices and vectors from mathematics. They are central to many scientific solutions. But how do we apply them in the computer programming? Simple. We can use arrays, isn't it? Here is a two-dimensional array, and here is an equivalent matrix. They look the same, isn't it? You refer to an element of the matrix such as A of ij. This notation is referring an element in the ith row and jth column. You refer to array elements in the same way, like this, right? So far, so good. But how do we perform matrix operations? Well, we can create functions and use them, right? Let's take an example and try it. Here is the example code. I am using Google Colab for this demo. You can use the same, or you can also use your Jupyter Notebook environment. I'm defining a function that takes two arrays, performs the dot product, and returns the result. Then I'm creating two random arrays, each having 1 million elements. In the next step, I'm computing dot products on these two arrays. I'm also recording before and after time, and showing the total time taken by the loop. Make sense? Great. The next section of the code is computing the dot product using the NumPy function. I'm again keeping track of the time taken and showing it. Finally, I'm calculating the ratio of the two timings and showing it. The final output tells how fast NumPy is working compared to standard Python code. Let me run it. Do you see the difference? The NumPy is exceptionally faster than standard Python code. Why? We will learn the reason later. But the speed and performance are one of the most critical reasons for NumPy adoption. The other reason is the memory footprint of the NumPy array. NumPy's array are stored more efficiently than an equivalent data structures in Python. Can we see it? Yes, let me show you. Here is the code. The first cell will install the Python memory profiler. Let me run it. The second cell will load the memory profiler extension. Let me run this also. Now, in the next cell, I can create a Python list and mem it. Let me run it and see how much memory do we use. So, the peak memory is the amount of memory that we use to create this list. Now, let me import the NumPy and create a NumPy array. Let me run it. Great. Do you see the difference in the peak memories? That's another reason for NumPy being so popular. Other than this, NumPy is an open source library and available to your organization at almost zero cost. Great. So now we know what is NumPy and why do we need it. That's all for this video. See you again. Keep learning and keep growing.